Okay, let's begin. Right. I think there are still students joining. Yeah, maybe let's begin in 1 minute. Right. I see students still keeping joining. Okay, let's begin. I see two chats. Yeah, good afternoon, everyone. Okay, so today we will talk about architecture, and by Friday, or today or Friday, we will finish this slide, and then we will release, the first quiz, okay, which will contain close to 10 questions for you to finish within 1 week. Okay, and this Friday we will also have the labs. Okay, so the lab will get you familiarized with Cisco packet tracer. Okay, so be prepared, and the tier will be there. Okay. Okay, let's begin. So this lecture is about architecture. Basically, we will review the layered models. Okay. Yeah, the quiz will be timed. So I see a question. So be sure you get prepared. I think everything will be already covered in the slides. So you be sure you understand the things in the slide, and then we will give you a timed quiz. But the time will be long enough for you to finish. Okay, so it will not be very hasty. Okay, the quiz will be released, and you can I think either tonight or on Friday, depending on when we finish this slide. Okay, and then you will have maybe 1 week that you can finish, and we are considering 1 to 2 attempts. Okay, we are still deciding. I think maybe 1 attempt is good enough if you review all the slides. Okay, and after that we will release the solution to you guys. Okay, and yeah, so this quiz is mainly on this slide. Okay, architecture. So not including. I think last slide is an overview. Okay, so you cannot say not including last slide, right? So mainly this slide. Okay. Thank you. Okay, we will be covering, most focus will be on the OSI layered models. Okay, and so let's begin. Right. So firstly, computer networks, we have a lot of functionalities, right? So we want to want to take it effect, right? So, and these functionalities, now we should know that they are implemented in different layers. Okay, and so networks are built from many components, right? So firstly, you need to connect to the network, right? In that case, you need some physical medium, right? So if you are in the lab rooms, that's in our building, then it will be using internet, right? So the desktop PC, okay? But if you are using your laptop, most likely you are using Wi-Fi connect to, our campus network, okay? And at home, depending on most people these days using Wi-Fi, because the computers these days do not have the port for Ethernet, right? So the twisted pair of wire. Okay, and there's also Bluetooth, right? Bluetooth is useful for more near distance connection, right? So all these are the physical media, right? So if you have a wireless headset, right? Usually it's using Bluetooth. Okay. And there's also fiber optics. Fiber optics is used for like data centers, and also for long distance transmission. You need a lot of bandwidth and low latency, so it will be useful. Okay, and cable modem and DSL are infrastructures to connect you from, let's say, your home to your service provider, right? So cable modem is from your TV, cable, right? So, and the DSL is from your phone line, okay, connect to the internet, okay? And so this is the physical medium, right? The different technologies, whether wired or wireless, right? So, and there's also different network styles. And we know that for internet from last lecture, right? So we should know now that we are using packet switched, right? We're not using circuit switch because packet switch is easier to share. Circuit switch is wasting the connection. Okay, it's dedicated, right? You hold the connection without allowing other to use. Okay, packets in the link you can share with other people. It's packets. Okay, and yeah, so the style, as we said, so Ethernet, for example, is wired, and Wi-Fi and Bluetooth, for example, are wireless. Okay, and optical is fiber optics, right? Because the light speed is much faster. Okay, and higher bandwidth, right? So, and also there's a satellite, and we already mentioned why we need satellite, because your infrastructure may not be nearby, right? So in that case, you have to rely on the satellite to relay the traffic to the backbone. In that case, satellite has a weakness, which is a very long latency, right? Say if you say hi to another party, maybe after quite a while, the other party will come back, right? So there will be some delay. Okay, it's not a problem. Latency is not a problem if you watch your YouTube video, right? As long as the bandwidth is high enough. But if you are chatting with somebody, you will feel it. Okay, and we have all kinds of applications like the email and browsing the web pages and maybe the online games. Okay. And there are so many different components. How do we organize them? Right? How do we make them work together? Right. So I see it in the chat. Oh, there's a student asking the circuit and packet switch again. So circuit switch is like just like a telephone network, right? So you call somebody, and the link is occupied by you. Okay, other people cannot use, right? But the packets are like basic units in networks, right? So if you send a big file to the other party, like 10 GB, right? But other people also are chatting with and you do some other traffics, right? These are, even you have 10 GB, but it's decomposed into very small packets, right? And then send so that the same link can be sending in the meanwhile, sending your 10 GB file, and then doing chat, send chat traffic and other traffics with other people. Okay, so that's not occupied, right? So not solely occupied by you. Okay, and it controls the speed using protocols, right? So congestion control, right? And these things are all actually functionalities that need to be laid out in different layers. I hope I answer your question. Okay. And the problem scenario, right? So let's think about the top layer applications and bottom layer, the physical medium, right? So the connection methods, right? So first layer, you can have applications, right? So let's say you want to use a browser, browse the web, and you want to receive email, maybe using Outlook, or you can also use the browser systems, right? And you want to do peer-to-peer file transfer, right? So, and these are different applications you have, okay? And nowadays, we have numerous apps, right? Because of the mobile apps, right? Developed, okay? And we also have different kind of way of connecting to the network, right? You can use Ethernet, and these days, Wi-Fi actually I think is more dominating. If you think, the laptops like the Mac Pro, this kind of machines are so thin, right? So you don't have enough like a thickness to have a port for this kind of twisted pair wire, okay? And you can also use Bluetooth, right, to connect to your peripheral devices, right? Headset and other like wireless headset, wireless, microphone, etc. Okay, or you can do short distance transfer of files. Okay? But because these are all different physical mediums, right? So one natural way to support application on this medium is that you can develop something, right? So on each medium to support the web, okay, right? So for browser. Then if you have a new, like you develop Outlook client, then you need to have three independent implementation again, right? And then if you have the P2P application, you need to have three implementation for different physical medium again, right? So that's kind of crazy, right? So, and the problem is that, these applications can grow, right? So if you have a cellular like 4G, 5G, right? So then, this is a longer distance, right? Because all these are more like a local area, okay? And if you, let's say if you are using mobile device, but your mobile device is, you are moving, right, in a car, usually you will not use Wi-Fi. Wi-Fi is in the same area, right, the same building, okay? And then you will be using the cellular, right, so the cellular network. In that case, now, for example, I added a cellular network, then we need to, let's say, support 4G for all three applications, right? Then they need to implement another one for 4G, right? Then that becomes even more crazy, right? And Then assume you have a Skype application, right? Voice over IP, okay? And then what you need to do is you need to implement 4 of them, right? And so this is a nightmare, actually, right? So you think about you have so many apps. This is very difficult to manage, okay? So the current solution of the internet is really, so before that, we will have another slide, okay? So another issue is that, right, so maybe one user of BitTorrent is using his PC or her PC, okay? So he's using Ethernet wired connection, okay? But another user of BitTorrent is using Wi-Fi, right? So how do we, right? So because the physical medium is different, right? So how can we communicate easily, right? Do we need the 2 implementations to be, there's some integration of the 2 implementations. Then there's the combinatorial, right? N square different pairs of those stuff, right? So then it's even less manageable, okay? So the current solution is really you have the layered model, right? So the last one is the last layer, okay? Right, so it's the mediums, right? So it's the last layer, okay? And the applications is the top layer. And we have a bunch of layers in between. And one of the most important layer that is shared, as we will see later, is IP layer. Right? Every device is given an IP address, and then you have up-level communication TCP, UDP to communicate, right? Okay, so this is, right now, let's assume this is the magic network layer, okay? This is abstraction, okay? Then everyone just follow this abstraction when you implement a new hardware device, right? So you just follow this, okay? There's a protocol to them, okay? And everyone speaks the same language in the middle layer. And if we do this, and the other side, we also have an abstraction API for the applications, right? So we know that it's like a TCP, UDP, this kind of end-to-end communication protocols, okay? And with that, then people can just use this interface, like a TCP, socket programming, okay, to develop their apps. They don't care about whether you are doing, TCP connection using a wired connection or using a Wi-Fi, okay? So this is called a use indirection to do that, okay? So this is the layered abstractions, layer by layer. Actually, this middle level has many layers. And again, so everything have an API. Right? This can be like if you have a hardware device and you have like a driver program to map to the API here, right? So that it's compatible, okay? And also there's topic programming at the application layer. And in that case, let's say if you need to devise a new application, let's say Skype, what you need to do is just using TCP or UDP connection. You don't care about what is down there. Whether you're connecting using Wi-Fi or using Ethernet. And similarly, if you want to support 5G, right, for example, okay, and in that case, you don't care about what application is running on top, right? As long as I support, the physical medium, the 5G really is the very low layers, the last layer in this abstraction, right? We can support its functionality. Then that's fine. All top layers, they will function as they are laid up, right? Laid up. So this is basically saying that we have a constant workload for each edition, right? We just look at the API that we want to adapt to, and then we do it, okay? So there's like a few limits on new technology, right? Because, you can add new apps, you can add a new, maybe we have 6G later, right? So then you can add it easily, okay? So here's the layout of the stack, the network stack, right? So we have a physical medium that we talked about earlier, right? So the Wi-Fi, the Ethernet and applications, we can have email or even mobile apps, okay, on top, right? And we have a lot of layers in between. This is what we will be describing in this class, okay? And here we need to look at the, so firstly, in between each 2 layers, we have ... right? This is actually the APIs. The APIs are actually not just one API, right? So you can have multiple. For example, here in application, you can have UDP, you can have a TCP, and you can have something else, right? MPI, etc. Okay. And here at the physical medium, you can also have a lot of different APIs. And in between these layers, you can have different APIs. Okay. So just keep in mind, it's just it's a bag of different APIs. It's not just an API. Okay. This is like the lower level function if you use programming. perspective, you have a set of libraries which is very low level, right? Maybe operating system functionality. And then on top, you have like a file transmission functionality, right? And then you have some user interface for API, right? So like file transfer, etc. Okay. And finally, you have web pages for you to upload, download, right? So these are like sub functions, right? So, but it's one way, okay? Here, this layer, all the implementation will use sub functions like here, and all these will use sub functions like here. Okay? So there's a conceptually very low level implementation to high level. Okay. And so this actually follows the concept of modularity, right? So what we want to do is, hey, if you are doing those kind of low level stuff, right? So how you connect to the network, right? Physical medium. We don't care about it, right? So when you develop applications. So if you don't have this layered structure, then you have to directly support this yourself, right? If you have an API that guarantees every sub-function properly switch, right? In which condition you use Wi-Fi, which condition you use Ethernet, right? So then it's fine, okay? So you just support using TCP UDP. That's good enough, okay? So this is called modularity. But again, so just like what we said, these layers are using standards, right? So IEEE, standards, okay, and but you just this standard just specify the implementation. It's just like if you think about this a function, right? It just tells you what's the input, what's the output, okay? How implement this function? It doesn't matter, okay? So everyone can implement their own, okay? So instead of telling how to implement this is the implementation's task, okay? And so this layered stack is just telling the API, okay, what you should achieve. Right? So this is what this modularity is talking about, okay? You just say how to organize the functionalities, what each should achieve, what's the desired functionality, but how to implement those functionalities. Different vendors, different protocols, they can have different, okay? And another important thing is that we have the concept of encapsulation. We will see that later. Okay, so basically, you can have the low level. Let me see where the mouse. You can have low level packets, right? A bunch of packets. But if you want to route into another IP, right? So you can have a so-called headers. Okay, we will see that later. Okay, with IP address, right? So in your low-level medium, you just care about the content of bits, how you transfer, right? You don't care about how you manage IP address, like in the IP layer. Okay, so this is called encapsulation. So your low-level stuff will be including high-level stuff around, and the high-level stuff around, again. Okay, then each layer just care about its header. Okay, maybe this cares about this header, this cares about this header. Okay, and this transfer. Actually, it's actually reversed. So actually, this is your content, right? Application as content, and then this layer you add a content. Okay, and this maybe add a two header. Okay, this adds two header. Okay, maybe this we don't only care about your IP address, how to route, and this layer just care about how congestion control and the other stuff, right? So and the final layer is where you care about, right? The web pages. Okay, you want to visualize the web page by asking the server. Okay, you don't care about its IP address, right? So in the application layer, we have the domain name, so you don't care about a lot of the details. But down there, the network stack is helping you achieve all those things, right? So this is encapsulation, and there's also flexibility, which we have seen before, right? It's a constant cost to extend a new module instead of care about all these different functionalities. Okay, and another important thing is this, right? So first, you use, right? So when you use TCP, this TCP you maybe reuse IP reuse Wi-Fi. Okay, so it's a reuse, right? It's just the functionality of like when you program the sub function, right? You write a sub function, like take an absolute value, then later you don't need to write the if branch, right? If larger than one, write x, less than one, minus x, right? So you can reuse this directly. Okay, and there's also another benefit of implementation can change. For example, if you have a new application, right? You can freely add an application, because even if, let's say, now in IP layer, we want to go from IPv4 to IPv6, right? That's fine, because as long as this layer is handled, right? This layer only need to take care of its nearby layers, okay? And all the other things, they don't need to care about this layer, right? So from application perspective, IPv6 and IPv4, we can directly, go there, right? So some more complicated stuff is how, the routers, for example, need to support IPv6, right? And it's not application developers' duty, and they can reuse their application without any change, okay? And there's some trade-off, right? So the interface will hide some information, right? For example, I think all of you have this experience when using object-oriented programming, right? So for example, if I have this interface, a class, right? And here I want to change an internal variable here, right? We cannot just say, hey, I change the internal variable because it may be private, right? We need to make sure it has an interface called setter, getter to change it, right? So then a lot of information you don't see, right? There's pros and cons, okay? The pros is that you most of the time there are so many details in the lower layer, right? So low-level details, you don't care, right? You just look at the high-level details. But what if, you do need some good idea that you want to utilize some of the components there, but it's not open to you, right? So then that's the trouble, okay? And another thing is that this architecture might hurt the performance, okay? So because, for example, if you think about it, this is also the same in everywhere, right? So in operating system, the lower layer is more efficient, the higher layer is less efficient, right? So, so for example, I believe if you use Linux or Mac OS, right? So there's a kernel space and your user space, okay? Kernel space is way faster than user space, right? Your code is written usually in user space, and when you call some functionality like send some like TCP or sending stuff to elsewhere, or you use a file system, it will switch to some library code in the kernel space, which are more efficient, okay? And for example, if you use Python, right, we talked about, I think in another course, if you also in that course, we talk about, there's also Python, using native languages down lower level to handle that. If you use Java, you know that Java has I/O, which is super slow. So there's a native I/O, which basically you see to write this I/O again. That's way faster in I/O. Okay, so lower layer is more efficient, right? But if you do, because the lower layer may just do some simple stuff, and even if you can do complex stuff, it's not doing that, right? Then you have to do that on top, like in your application. And even for the same job, if you do it here, it will be much slower, maybe 100 times slower. Okay, so that means the performance can be hurt. Right? Any questions so far?
Yes, sir.
Okay.
So basically, modularity means they only input and output is important. The way the output is, the way they get the output is not important. Only the output is important, right?
No, this data format is important, basically, right? So when I use input output, I'm talking about the programming because this may be more familiarized with you guys, right? So, but in computer networks, we are talking about protocols, right? So let me give you an example. For example, in machine learning, we have, for example, if you look at the symmetry as an example, okay? So the reason we want to use this kind of modularization idea is that we really just want to care about what's the input, right? So these are the input, okay? And then what's the output, right? Returns what, okay? And how this thing is implemented, we don't care. Okay, so this is how you look at stuff, right? So when you call library, the internal implementation, as long as you know how it functions, it's fine. But in computer networks, let's say TCP header, so we are really talking about those kind of protocols, okay? So again, it's how data is organized, right? So you think about if it's the same structure, okay? If your packet is of the same structure, then no matter how you implement, right? So how you set this flag, for example, and how you do checksum, right? How you get the IP address and port. As long as you follow this format, the other side can also get it, right? So you can, for example, using socket programming C API in your machine, and the other side using Python, it's the same, okay? So here we are talking about, if you talk about the interface, okay, this interface in network is more like the data format, packet format. Is okay?
So basically, it's just the format, right? If it is like, for example, the TCP/IP header, if like the checksum flag, if it is organized in that way, the other layers can use it. So basically, that's what modularity is.
Yeah. So basically, it's an interface, right? So it's like what programming we know it's more intuitive because it's a user interface, right? UI, user interface. Right? So here it's the format, right? It's standard. Everyone follows the same standard. It may not just be the format, right? So the format of the packet is one thing, right? How each packet, what's the semantics, what's the meaning, how they functioning, right? So there's a protocol, step 1, step 2, step 3, right? Like three-way handshake, etc. Okay, but these protocols, once it's determined, the implementation is not important. Okay, this is more like an interface. The reason I'm talking about functions is because it's more intuitive if everyone uses some libraries. So just to give you some high-level intuition. Is it okay?
Yes, sir. Yes, sir.
Okay. Let me get my mouse back. I see the chat again. Okay, let's continue. So yeah, so there are so many different kind of functionalities, right? So for example, you want to route the packet from one side to the other side, right, using IP address, and you want to ensure security, right? So for example, if you are purchasing some product on Amazon and you need to transmit your transaction as a credit card number, etc., you need security, okay? And there's also congestion control, just like I said, right? So if let's say 10 people are all in the same building downloading a big movie, right? If that happens, let's say the movie is 10 GB, right? Very high resolution. In that case, you need a congestion control, right? Everyone should download with limited bandwidth, right? They should share the same bandwidth, okay? So there's also fairness, right? This is a congestion control and fairness, right? You cannot download too fast. Other people will have no speed. Okay, so these are also very important. Another error checking. Error checking can be causing various reasons. Okay, one kind of reason, if you heard of the balancing error, right? So if there are radiations around and your while can flip a bit from 1 and 0 to 1 or 1 to 0. Okay, so you want to avoid that from happening. Okay, if that happens, you need to detect it and ask the sender to retransmit. So we have a lot of functionality in the network that we need to achieve. But how do we distribute the functionality across devices, right? And so also across layers, okay? So each device itself has many layers. Okay, maybe some device only have some layers, okay? And the bottom layers, some have all the layers, okay? But basically, when we say we distribute the functionality across device, we are distributing according, across the layers, okay, of the network. So here is the example, right? So there's a host, there's a router, and there's a switch, right? So these are different devices, and how do we distribute the functionality among them, okay? And so we have two big topics in this slide. The first is a layering model, right? So what are the layers, and what's the functionality of each layer, okay? The second is, an end-to-end agreement, right, which is followed by current internet design. And we need to understand what's the end-to-end agreement, i.e. Okay. Okay, first let's take a look at the example, right? So to pay attention that, we have 3 devices, right? Host 1, host 2 may be in the same building, right? So we just need a switch to connect them, okay? And each device, let's say in your PC, you implement all the layers, okay? You implement all the layers, like here. And let me change the color. This color. You all the which color could be bad, could be good, maybe bad. Okay. You can all the layers, but in some devices like switch, you only implement some bottom layer because you don't care about application data, right? So you just care about how to go from this IP address to that IP address, connecting. This is switch we talked about, okay, earlier. And another thing is that you really don't want to switch to know your data, right? Because since they can hack your data, right? So there's no need because reading it takes time. And another thing is that it's security concern. So different devices implement different layers. The bottom layers also always implement, but the top layers may not all the way to the top, okay? Because top layer depends on the bottom layers. You always need to implement all the bottom layers, okay? And here are the names of the layers, right? So there's a way to remember, right? So all people seem to need all data processing, right? A, P, S, T, and DP, right? So, but I would say that Some of the layers are not that important. Let me put them out. Okay, so presentation layer, really it's not so important. Okay, session layer is not so important for this code. And the physical layer is not so important, but we will cover them. Okay, so you need to have, because maybe 7 layers is a little bit overwhelming for you to remember. First, you need to remember we have different applications. Okay, and then we have the socket programming that you will be doing very soon. Okay, so this is UDP, TCP. Then we know that this transmission need to do the routing. So we have the network layer, IP address. Okay, and the IP address is not directly to the destination, right? We also need to have the routers. Each router also have their IP, right? So it's for routing purpose. And then you have also the data link layer, right? So the data link layer is more like the medium, right? Ethernet. Okay, so it cares more about less than routing. It cares about, let's say routing is you go from here to here. And the data link layer cares about how you connect, right, locally from it. Okay, so this data link layer. So these 4 layers are the most important layers. Okay, and we will cover. And frankly speaking, the physical and the session layers are just the original proposing OSI, the 7 layers model. But actually, when people actually go about and implement them in the current internet, okay, architecture, we don't have explicit presentation and session layer. Okay, most of them are connect with application layer. Some goes to transportation layer. Okay. Any questions? But this is what you need to memorize. A lot of students ask whether we ask you guys to memorize something, right? So these 7 layers you need to memorize them. Okay, so it's like the history, years, or things you know. Okay, and application, transport, network, data link. Okay, you should have very clear idea what they are doing. Okay, this is the basic requirement of this code. Okay. Any questions before we go on? All right, so if not, let's continue. So all the devices will implement the network link and the data link links. Okay, so including switch, including router, etc. All of them will implement. This is very simple, right? Because network layer is helping you to route multiple hops, okay, to the destination, right? And the data link layer is used by the network layer, right? So within one link, how it happens. Okay, so of course, when you transmit like those connecting devices, they need to implement all the bottom 3 layers. All right, let's continue to the next slide. Another important thing you want to keep in mind is that the communication is peer-to-peer, end-to-end. Okay, so for example, for physical layer, because we just care about one hop, right? So how to connect your device to the wireless router, for example, using Wi-Fi. So this is a physical layer, right? So and then the protocol, maybe we use Wi-Fi, and then this is a data link layer, right? From your laptop to your wireless router. Okay, and on top you have the network layer. It's still network. Network is actually we still use the hop by hop because when you transmit stuff from your side to the other side, maybe in another state, for example, right? What you do is you first look up the destination to get it's directly to the host, right? Because you are not directly connected to the host. You connect to the next hop router, okay? And there's a lookup table. If you want to go that direction, who you should contact next, okay? So it's like this, and you do this again and again until you reach the destination. So again, it's more like one device to another, right? From your host to the router, okay? But above this is actually now you don't care about how you route, right? Because the path selection, this stuff has been done by the network layer, okay, routing layer. Then transmission layer, transport layer, you just care about from one end to the other end, right? So how do you lay it on top of the IP layer? TCP, UDP, how do you transmit your data, okay? Right, and for example, TCP has congestion control, we mentioned earlier. Without congestion control, everyone will be dropping packets and retransmitting, okay? And so this is, in this side, you only care about the source and the destination you want to contact. Right? And there's also session layer and the presentation layer of application layer. All these layers is also end-to-end, which means who you come to contact is the host 2, and this is the host 1. Okay. And because the bottom layers is you care about routing, where to go next. It's a bit in between each hop. Okay. Yeah, TCP is having congestion control. Okay, TCP is in the transport layer. Okay, so TCP, UDP, all these things are here. Okay, so now their network layer has no congestion control basically. Okay, network layer do very simple things. If you have a packet to me, I look up your destination and I tell you where you should, where the next router is. Okay, this is routing. Okay, this is IP. Okay, on top we have TCP. Right, so TCP then say, hey, how fast you should send the packet to the IP layer. Okay, so that's a different. So that's different functionality that are divided across the layers. Yeah, because I'm answering a question by a student. Yeah, here's how things are going, right? Let's say when you send it from one host to the other host may be in the same building, so we just need a switch, we don't need routing. Okay, so what happens is that you have a web application, right? You go all the way to down layers, and then in the physical medium, you send to a switch. And the switch will then help you route to the right destination, okay? And then the data will be unwrapped on top to the host 2, and then the host 2 can see your data, okay? And keep in mind the switch, right? So we talk about hub, switch, and router. What's the difference? Okay, so switch is really connecting everything into physical medium, but unlike hub, only host 1 and host 2 will see the data. Host 3 in the same media kind of will not see the data. Okay, in your even though in the same Ethernet, for example, subnet, okay, it cannot see the data you send from host 1 to host 2 because the switch basically says I just route send data to that port. I don't send to host 3's port. While if it's a hub, host 3 will also see it. Okay. Okay. So next is layer features. We will talk about one layer after another. Okay. So for each layer, we will talk about these 3 things. The first is service. Right? What is the layer doing? Right? So for example, we talk about congestion control. It must be in transport layer. Right? So each layer has its own functionality. Okay. And another thing is what's the interface? Right? How do you access this layer? Okay. Usually it's by the top layer, up layer. Okay. And another is a protocol. Okay. How is this a layer implemented? Usually it's not just a how, right? Because how the implementation doesn't matter, right? Protocol is what's the implementation goal is like, right? So what should the implementation achieve? Okay. But you can use different ways of implementing as long as following the same protocol. So here is the physical layer. We will go from bottom up. And this will also be the organization of this course. Okay? So another textbook which uses a top-down approach, I think that's actually quite scientific. So you can combine these 2 textbooks we recommended in the previous announcement to take a look. Okay. And so in the physical layer, we know that we have different kind of physical media, right? So I think maybe I already have a you're already having a, let me see, I should have something shipped. It's fine. So firstly, you will have physical layer, really different physical media, right? So for example, coaxial cable is something like this. Okay, so let me show you. I think there should be some picture. Yeah, I'm not sure whether you have checked this kind of thing, right? So you have this, you can connect cable to your TV to connect to some port on the wall, right? So then you can watch your TV, right? Because it's connected to the backbone service, right? So this is the coaxial cable, okay? And there's also fiber optics, which are what we showed in the data center, right? There's so many, those kind of lines, okay? And there's also, radio frequency transmitters, right? So this is long distance, right? So you can use the radios to contact others, also transmit stuff, okay? And usually, I think you think about wireless, right? Wireless router is kind of using this kind of thing, okay? And so these are the mediums, right? So you are using air, or you are using some metal here, or using light. Okay, so this is the medium. And so what's the service that the physical layer is providing? Okay, it's just moving information between 2 systems connected by a physical link. So this is really within one link, one hop. For example, you are connecting to a wireless router, which connects to the internet, right? The service provider, and the connect to the other. Here we just really care about the first link, right? So we just care about one link, okay? So this is a physical medium, just between 2 systems that are physically connected, okay? Using some medium. including the ear, right? So because the technology is Wi-Fi and 5G, right? So depending on that, the distance will be different. Okay? And so the interface is really bit, right? So that's why whenever we talk about something in the computer, what's a file size? What we will use a megabyte, right? But when we talk about something on the wire, right? So we'll use NBPS. Okay. So what is BPS? Okay, so BPS is bits per second. Okay, bits per second is equal to BPS. Right, so you will have GBPS, MBPS, KBPS, etc. Okay, we are really thinking about the signal is sent one bit after another. Okay, the reason is because we will cover that in next slide. Right, so if you look at electronic signals, right, so it's analog signals, right, and we are really using some threshold to decide, or encoding method to decide whether this signal is 0 or this signal is 1. Okay, so these signals are really transmitted one bit at a time. So that's why we always use a bits per second, okay, to represent it. Okay. While in the computer systems, because everything in the computing, in the CPU, like when you do addition, it's integer, it's 32 bits, right? 4 bytes. Okay, so we are using this kind of word, right? Byte, word level, okay, word level. This is really bit level, okay, when we talk about mapping, especially about the transfer of data. I see some, okay, yeah. Okay, so keep in mind, when we talk about the speed of the network, it's always bit per second, BPS, okay? And the protocol is really the encoding scheme, right? So what kind of encoding scheme, right? You have 1-0 bit stream, right? So how to encode it to this wire or to the air, right? And 1 bit at a time, okay? And we will see some encoding scheme in next, maybe the next or the one after next the slide, okay? And it's really the different type of voltage levels, right? Whether it's high, it's low, and then you use some threshold or encoding scheme to decide whether it's bit 1 or bit 0, okay? And there's also a timing of signals, right? Because there's a clock in some sense, right? So if you have 3 zeros and you are just saying it's off, right? So 3 clocks of zeros is different from 1 clock of 0. 3 clock of 0 is 3 zeros, okay? And so that's a physical layer we talked about. And next is a data link layer, right? So data link layer is more than bits, okay? It's called a framing, right? So we do care about now, because we are doing packet switching, right? So we will break, let's say you have a 10 GB movie, okay? And if you just let everyone send this 10 GB movie, other people will not be able to use the same link, right? To, let's say, from building 1 to building 2, okay? If you just are using circuit switching, then that will be created. Let me use, for example, this is your house, and this is another, like another people, right? So in my house, for example, right? So I'm teaching, for example. But what if in the meanwhile you are getting a big file, like 10 GB file from me, okay? If using circuit switching, right? So then all these communications will be blocked, okay? So the solution really is that, instead of having this big movie, right? So we will break it into small packages, okay? We'll have this many small packages, okay? And when we have other packages, like in the chat, we have the chat stream, right? So these other packages can also go along this line, okay? But of course, the trade-off is that you are not fully utilizing the bandwidth, right? So it's shared, and your movie will transmit for a longer time, okay? That's all it takes, but so we need to do data framing to organize your data into smaller packets, okay? So data link is handling the packets, right? How to pack them, okay? And because they are accessing the same, usually it's shared physical media, because you think about physical media is the same media in one hop, right? Whether it's an air or it's an Ethernet link, right? So it's the same medium. So we need some medium access control. And we will see a lot of protocols for that, okay? So the reason we need a medium access control is because you think about it. If, let's say, you are nearby each other, connecting to the same wireless router, if everyone is sending stuff together, then the signal is corrupt, right? So just like you are speaking, but he is also speaking, right? Then you cannot recognize who is speaking, what's the word, right? Because they are kind of added together, okay? So medium access control or MAC is really something. What it does is make sure when people talks at a time. Okay, so this is because it's a shared physical medium. Okay, and when you connect to this medium, right? So actually, each host that connects to the medium has a MAC address, right? This is also called NIC, right? So each network interface card that you install in your computer has a MAC address. Okay, and in the old days, if you install your PC, you will have like a network interface card you can buy and insert into your motherboard, right? So you can support Ethernet and if there's a new technology like InfiniBand or other stuff like wireless interface, you can all have them. Right now these days, maybe your motherboard is integrated with these things already. You don't expose to these things, especially for laptop, right? But there's each device, right? So each device has a MAC address. Okay, you can use, for example, in Windows, it's a IP configure, right? And it will show all the interface, right? So each interface is a NIC, network interface card, and it has its IP address. Okay, in Linux or Mac, you use IF. And again, this is let me see. I think there's a so there's a question asking virtual machine have the same MAC address as a host machine? No, virtual machine is something like so this is your host. Okay, you are using cloud, and cloud create a virtual machine for you. Okay, so virtual machine are doing its job. Okay, but virtual machine is doing its job, right? Uploading data from its on the cloud data center. Okay, what you do is it's kind of building like a remote desktop visualization for you. Okay, right? But it's a different technology. You are like using this, but in between you two, it's still like it's at application level, like using browser to look at. If you use some like a panel of the cloud service provider. Okay, so it's not sharing. Okay, this is your home. Right? This is the data center. Okay. Oh, I think I assume you are talking about the cloud virtual machine, right? VM these days. But if you are using your own virtual machine, then that's a different story, right? So if you use a VMware, etc., then yes, you are sharing the same network hub. Okay, it may virtualize one internally. Okay, but it's like I think it's sharing the same medium, but you can also simulate one. If you are virtualized on your own machine, it's a different story. Okay. I may not be able to check the chat very frequently, so yeah, so there may be some delay in answering questions. Okay, and so we do just care about the one hop, right? And oftentimes the first hop, because the others we will leave it to internet service providers. For you, the most important is how you connect to the internet access point. Okay, and there's some flow control. Okay, there's still some reliability and flow control. For example, if some bit is flipped by some radio signals, right, and something is wrong, then it will detect it as retransmission. Okay, or sometimes it can auto-correct the system. Right. And so the interface is sending in the unit of packets, okay, between two hosts. Right. And physical is 1 bit, right? So packets is a little bit larger than 1 bit, okay? And all above actually is just adding headers to the packets, right? So, no, so actually, how to say, this packet is already adding a lot of headers. All above layers are taking out the headers. Maybe that's a more accurate way to describe it, okay? And the data content is in there. So there are 2 parts in the packet. Okay, one is control information, one is actual data, the payload. Okay, and the control information, each layer will add some control information. Right? So the whole thing is packet. Okay, how to break things into packet is their duties. Right? When you add a new packet, header, okay, and I think we covered basically all these. Okay, so the common protocols in this data link layer is like Ethernet. This is where when you connect to PC, a bunch of PC in the lab, it's using Ethernet. Okay. We also have Wi-Fi, where you just connect to the same wireless router. And there's also DOCSIS. Right? So I think we will end today after looking at DOCSIS. Right? Basically, this is a protocol to connect your, when you connect to your internet to your building, right? So you're usually using, a box that is also shared with a TV and use a cable to connect. Okay, in that case, it's actually you are using the DOT6 protocol. Okay? So they are all. So the downside is that they're all using the same bandwidth out to the service to the head end. Okay, out of your building. So all these different. If you are living in an apartment, right, all these tenants in the same building are sharing the bandwidth out. Okay, and there are some ways of how you share the bandwidth, right? Different people are using different fractions of bandwidth, so there are protocols. Okay, I think that's all for today. Thank you, and we will continue on Friday. If you have any questions, just let me know. We are not taking attendance today, but we will randomly sample some of the dates to take attendance. Okay, so maybe we will take attendance on Friday. Have a good day. And the quiz will maybe, I think we will release it on Friday because we just covered maybe 1/3 of the stuff here. Okay, and when we release later, we will also have a deadline that is later, so you will give enough time to complete. Okay, have a good day. And I think the video we will share on YouTube once it's ready. Okay. Yeah, the quiz will be on this particular slide. Okay, this particular lecture. Okay. Okay, have a good day. So if you have no more questions, I will disconnect. And if you have questions, you can send me email, and you can also contact the TA. And the TA office hours should already be released. If you don't know, just send email to us. And see you on Friday.